Clouds are the visible evidence of processes taking place in the air, the garments of the weather, so to speak, which change continually as the weather changes. In fact, the changes of the cloud garments in many cases precede and foreshadow changes in the weather. Thus, the cloud is not only one of the most beautiful and inspiring of the manifestations of nature, but it is of practical value as well, for it indicates the probable weather conditions for the immediate future. Indeed, if you know your clouds well enough, you can do a pretty fair job of forecasting for perhaps a day ahead, subject, of course, to upsets due to factors beyond your ken. For ages, farmers, hunters, and mariners have used clouds as weather signs. Changes in weather and in cloud forms are due to the passage of different air masses associated with wind systems called cyclones. This true cyclone, not to be confused with a tornado, is a great counterclockwise wind system, perhaps 2,000 miles in diameter, moving from west to east about 600 miles a day. The center of this advancing whirl is a point of low barometric pressure between areas of higher pressure or anticyclones. Cold air masses are usually found east, north, and northwest of this center, with a warm sector to the south. Thus we have a warm front with easterly shifting to southerly winds, then a warm sector with southerly winds, followed by a cold front with winds shifting to northerly. Where warm, moist air overrides cold air, there is precipitation, rain or snow. Taking a vertical section through this diagram and changing our viewpoint, we can illustrate the progress of these fronts. Starting at the axis of the anticyclone, where the barometric pressure is high, let us watch for 3 or 4 days while the cyclone passes. Think of the space above this imaginary warm front line as filled with a mass of advancing warm air flowing up over a dome or ridge of heavier cold air. This warm air is moist, and as it is lifted and cools, different cloud forms develop at different altitudes. As the warm front at the Earth's surface approaches, there is rain or snow. This precipitation is generally steady and light to moderate. Fair weather follows as we enter the warm sector. Here, warm air ascends by convection, owing to the heat of the sun, and presently clouds begin to form. As the weather grows warmer, these clouds grow heavier, and as the warm sector passes and the cold front approaches, they become dense and threatening, culminating in heavy rain as the cold front passes. This is the so-called squall line. Then the clouds tend to dissipate as the northwest winds bring in cold descending air. And finally, we are back to where we started, in a high-pressure area. So much for the phases of the typical weather cycle, which is most pronounced in winter, less so in spring and fall, and often interrupted in summer. Now let's study the types of clouds that usually mark the progress of such a cycle. Starting after the passing of a cold front, we have cirrus clouds, sometimes called mare's tails. These wispy clouds of ice particles are the highest of all, floating at an elevation of 25 to 30,000 feet above the earth. The wind is from the northwest, barometer high, temperature cool. Cirrus clouds may be followed by cirrostratus, which may merge into cirrocumulus, sometimes called mackerel sky. Next, not quite so high, we may have altocumulus clouds. Meanwhile, the wind is northerly, temperature cool, barometer still high. Lower down on the frontal slope, we encounter altostratus clouds, generally with northeast winds, falling barometer, and steady or slowly rising temperature. As the warm front approaches, the wind swings to the east with nimbus clouds and rain or snow. As the warm front passes, the wind veers to a southerly direction. Bear in mind that shifts in wind give a general indication as to what sector of the cyclone we are entering. Then the sky clears, and we have fair and warm weather for perhaps a day, with southwest winds and steady or slowly falling barometer. Scattered cumulus clouds appear at an altitude of 5,000 feet or more, gradually becoming heavier as the temperature rises. As the cold front approaches, the clouds often rise suddenly into threatening thunderheads, mountains of cumulonimbus clouds, towering to a height of possibly 30,000 feet. As the tip of the sloping cold front arrives, nimbus clouds form at the base of the cumulonimbus storm cloud, and heavy showers occur. This is normally a brief but violent rainstorm. While the cold front is passing, the temperature falls abruptly. The wind shifts to the northwest. The barometer rises, and we may have a rainbow. Soon thereafter, the storm clouds give way to fractocumulus clouds that rapidly dissipate. Thus we come back to the sector of fair and cool weather, and the cycle is complete. So much for the practical aspect of clouds, the aspect that outdoor men study daily for indications of the weather. The beauty of the cloud is quite another matter, yet one of prime importance to the human spirit. Indeed, there is no one feature of the average landscape that may add more to its charm and appeal than beautiful clouds. Try to make a worthwhile picture of a flat plain like this without clouds in the sky, and you begin to realize the aesthetic importance of clouds in this world of ours. And even when they are not inherently beautiful, clouds may have much charm and interest. The fog that drifts over the peak of Mount Tamalpais, though merely a gray mist to the observer on the mountain, has an appeal to the lover of nature, an appeal which may be heightened by the knowledge that the altitude of the observer has much to do with the type of cloud as it is revealed to his eyes. Thus, one man's fog may be another man's stratus. From San Francisco, this fog appears as a high stratus cloud encircling the top of a distant mountain. From the slope of Pike's Peak at sunrise, we look out over a sea of fog, stretching level and unbroken to the horizon. If we were in Colorado Springs, 2,000 feet below, this fog would be a broken sheet of low stratus clouds, which would soon be dissipated by the heat of the morning sun. As we look at this view of Mount Hood, the cloud we see is a streak of fractocumulus. To the mountain climber, it is a fog. Thus, these fractocumulus clouds about the summit of Mount Shasta, though they look serene enough to us, sweep over the glaciers of that lofty peak as a cold and forbidding mist. From all this, it appears that we might well take our clouds more or less seriously. Though most of us cannot hope to acquire the instinctive weather wisdom of the born hunter or sailor, to whom the sky is an open book, we may at least find pleasure, and perhaps some profit, in trying to understand those riddles written in vapor that pass overhead. Day unto day uttereth speech, and night unto night showeth knowledge. And to be able in some measure to interpret that speech is to have a fuller appreciation of the significance and beauty of the cloud, a keener sense of the majesty of the gathering storm, of the splendor of the sunset, of the incalculable variations in color and form that lend meaning and beauty to the magnificent pageantry of the weather cycle.